on Chapter 2, Section 2, and Chapter 2, Section 3. As you can see, there's a lot to be done, but a lot of this is review from Algebra 1, so hopefully this will spark your memory a little bit and you'll remember this stuff. We're going to look at direct variation, linear functions, and slope-intercept form today, okay? So again, like I said, hopefully this is review and you remember this stuff, and if not, hopefully we catch you up enough to where you are good to go. So let's start with looking at direct variation. Some of you will remember that direct variation is very easily seen as this, right? Oh, where am I? There you go. As this right down here, y equals kx, or y over x equals k, where k is not equal to 0. K is the constant of variation. A direct variation equation always goes through the origin, and it's typically related to like common sense, or more common at least, word problems, things like, you know, if you babysit and you make $5 an hour. That's a direct variation equation because you are, how much you make varies directly with how many hours you work. The y-intercept is 0 because if you work 0 hours, you get 0 pay. So really simple kind of word problems like that. Sometimes what we have to do, though, is we have to be able to identify direct variation. So, for example, in number 1, which one of these is a direct variation? The easiest way to do that is to remember that the equation for a direct variation is y equals kx. It's just like y equals mx plus b, except for we changed m to k because constant, and math teachers don't know how to spell, so it's not a c. And we don't need a b because it's 0. It goes through the origin. So if you can remember this, all you have to do is we want to know if the constant of variation is the same each time. If we take this equation and we divide both sides by x, okay, then we end up with k equals y over x. So same equation, we've just manipulated the way it looks. When we do that, what we're able to do is we're able to look at a table and say, all right, 2 over 1 is 2, 6 over 3 is 2, 8 over 4 is 2, so no problem. They all have, the k is 2, the equation is y equals 2x, so that is a direct variation. We take a look at this one, we have 4, 4, and then 11/3. It's not constant, it does not vary directly. Very simple stuff here, okay? So try these, take a second, pause the video, try these and see if you get a constant variation, and if so, this is an important part because sometimes we don't read all the directions. If so, what's the constant of variation and what's the function rule? Go ahead and pause the video now and get some answers to that. Pause the video. Okay, so you've unpaused. Hopefully you got the same things I got. A was a yes. The constant of variation is -7, and the equation is y, or the rule, the function rule is y equals -7x. Here it's a no because these fractions don't equal each other. Easy enough. How to identify it from an equation? Okay, so for each function, determine whether y varies directly with x. If so, what is the constant? So from an equation, basically, can you get it in the form y equals kx? Can you use your algebra skills to get it in this form? All right, so if we take this one, we divide both sides by 3, we get y equals 7/3 x. Is 7/3 an ugly number? Sure it is, but let's not judge it by its cover. Maybe it's got a great personality. Either way, there's nothing after here plus b. There's no y-intercept, and because there's not, that is a direct variation, and the k is 7/3. If you look at part B, when we get the y by itself here, we end up with y equals 2x plus 1. That right there, that plus 1 keeps it from being a direct variation. All right? So let's take a look here. Are these two a direct, are these guys, A and B, are those direct variations or not? If so, what's the constant? Pause the video here and try A and B. So hopefully you got the same thing I got, that both of these are direct variations. Here we solve for y and we get y equals -5/3 x, so k equals -5/3, that one's a yes. Here, same thing, y equals 1/9 x, so that's a yes, so k equals 1/9. Again, no problem. Let's take a look at number 3. Suppose y varies directly with x. So now we're telling you, when it says that, it is telling you, you have a direct variation. This is telling you, you have a direct variation. So the direct variation rules apply. All right? So y varies directly with x. Y is 9 when x is -15. Well, what is y when x is 21? Well, very simply, we can use a proportion to solve. If it's a direct variation, they should have the same proportion. They should equal the same ratio. So I can say 9 over negative 15 equals y over 21. I make sure that if I put negative 15 on the bottom, I put 21 on the bottom because they are both x's. Okay? Easy enough. Let's go ahead and try this one. We'll do this one together so I can make sure we're setting them up right. Suppose y varies directly with x. It's telling us. Y is 15 when x is 3. So that should equal, what is y? So y, we don't know, when x is 12. Okay? Go ahead and solve that proportion. Some of you are doing that faster than others, and hopefully you're getting 60. All right? Some of you cross-multiplied. That's fine. Others of you that are more kind of like number savvy, notice that you multiply 3 by 4 to make it equal to 12. So multiply 15 by 4, and that's how we get y equals 60. No problem. So using direct variation to solve a problem. Again, what I said at the beginning, a lot of these are real-world situations, so the word problems are pretty common here. So we have a salesperson's commission varies directly with sales. Shocking. For $1,000 in sales, the commission is 85. What is the commission for 2,300 in sales? Well, that's really easy. What we do is we find what's the constant of variation. Okay? When we know the constant of variation, then we can solve it. So if the commission is 85, okay, on whatever the constant is of 1,000, then we get k equals, and you can leave it as 85 over 1,000, or you can write 0.085, either way. That's what they did down here. Then we're going to take 0.085, multiply it by the 2,300, and we get that. Okay? We can apply the constant. If the constant is if it is a direct variation, then the constant is the constant no matter what we do. The number of calories varies directly with the mass of cheese. If 50 grams of cheese contains 200 calories, how many calories are in 70 grams of cheese? Okay, so let's take a look. Sometimes, if you don't want to solve this finding k, which is not very hard, you could just set up a proportion again. If it varies directly, 50 over 200 equals how many calories are in 70 grams of cheese? So 70 over, x, all right? And then solve for x. So when we do that, what do you get? Go ahead and pause the video, get that answer, and do part B. Do that now. Pause. So here's what I got, and hopefully you got too. I got 280 here. And over here I got no, because if y squared varies directly with x squared, when we solve that for y, we get plus or minus the square root of kx. And that would mean that sometimes k is positive, sometimes it's negative, and because it's not the same every time, it's no bueno. It doesn't work. All right? If you have more questions on that, let me know and we'll talk about it in class. The graph of a direct variation function is always through the line of origin, okay? So that's what I said at the beginning. It's always going to pass through the origin because of the real world value of it. Go back to the commission one up here. If you make 0 sales, your commission is $0. If you have 0 grams of cheese, then it is 0 calories, which is a great diet plan if you stay on the 0 grams thing. So, what is the graph of each of the direct variations? Okay, so A, y equals 3/4 x. So, the easy way to do this is divide both sides here. Y equals 3/4 x. So, sorry, hold on one sec. So you're given this, y equals 3/4 x. You can just plug numbers in, get points and graph. Very simple here. Very, very simple. Same here. Just pick some values, plug them in for x, get some y's, plot some points, good to go. Making sure that it goes through the origin every time. So what would the graph of these two look like? Okay, what would the graph of those two like? Give yourself a sketch. It doesn't have to be perfect. I'll make mine nice and imperfect so we can be the same. Y equals negative 2/3 x. If you want to give yourself a t-chart, x and y, and pick some numbers, I'll pick -3, 0, and 3. I picked those on purpose because I'm trying to make it easy on myself. Over here, x and y, I'll just pick -1, 0, and 1. Okay, so when x is -3, that's going to be -2/3 times -3, which is, well, we know it's positive. The 3's cancel. It's 2. So -3, 1, 2, 3, 1, 2. There's a point. 0, well, anything times 0 is 0, so we know it goes through there. And then when it's 3, it's -2. So 1, 2, 3, 1, 2. So there's that, and there's no way I'm going to connect these well. That's pretty good. Okay? Go ahead and pause the video, find these values right here, and unpause it, and then see what you get. All right, so there's mine. Again, making sure that every time it goes through the origin. That's a big key. All right, that's it for direct variation. Let's look at linear functions and slope-intercept form. Again, I'm going to go pretty quick. This should be big time review for us. We should be pros at this, to be honest. Slope, we know that slope is rise over run, rise over to run, which means y's on top, rise, y's, they rhyme. Isn't that convenient? Y2 minus y1 over x2 minus x1, again, delta y over delta x works for me. If you want help me explaining that in class, I'm happy to do so. Delta is the Greek letter. It means change. Okay, but slope, we should be pros at. So, problem 1, find the slope of the line that passes through the given points, guys. Got to be able to do this, okay? Gots to. You gots to, right? Gots. That's weird to say it like that. Pause the video here. Do 1A, B, C, and D. Ready, go. Did you pause? Pause. All right, here we go. -1, 1, undefined. That's when the zero's on the bottom. And at the last one, all this is proving is that it doesn't matter which order you subtract them in as long as you subtract them correctly. I would argue it's even easier to give yourself a quick sketch. 5, 4 is right here. And then 8, 1 is right here. So I know, that line's terrible, but I know that that line is going down. So I know that that slope is going to be negative, so then all I have to do is calculate difference. Take a look down here. Concept summary, this is a big deal, got to know this. Positive slope, negative slope, 0 when it's flat, 0 like the letter Z makes it flat, and undefined. Some people draw a big capital U, and so it's undefined. So that's a way of remembering that it's vertical. All right. A function whose graph is a line is a linear function. Okay, linear equations you worked with a lot in Algebra 1. A solution of a linear equation is any ordered pair that makes the equation true. All right, any equation that makes the ordered pair true. So a special form of a linear equation is called slope-intercept form. You guys know this better as this. Y equals mx plus b. We need to be familiar with y-intercepts and x-intercepts. It's where they cross the axes. And then we just need to be able to put in some stuff. And I mean, gosh, guys, m equals 1/5. The y-intercept is -3. We should, that's that. Okay, that should be pretty easy. Let's try number 2. Let's try number 2. So the slope is 6, so y equals 6x. Y-intercept is 5 plus 5. That's it. B, the slope is -1/2, so y equals -1/2 x, and the y-intercept is -3. Easy enough. Using the graph in part B, do you get a different equation if you use -6, 0, and the y-intercept to find the slope of the line? If you use this point right here, you go down 2 over 4, but down 2 over 4 reduces to -1/2, so it's no, but we must reduce. Okay, must reduce. We can rewrite equations that aren't given to us, and again, we did a lot of this. That's a whole unit in Algebra 1 where we rewrote equations into slope-intercept form when we were given in another form. That's just using your algebra skills to solve for y, okay? So take a look at the examples they give you there at A and B, some strategies to use. I know that we don't love fractions, so usually the easiest way to get those is work with those is by getting rid of them at the very beginning. Go ahead and pause the video here, try 3A and 3B, and then we'll check your answers to those in just a second. Go ahead and pause the video now, please. So hopefully for the first one, you got the equation y equals -3/2 x plus 9. Slope is -3/2, y-intercept is 9. Over here, y equals -7/5 x minus 7. Slope is -7/5. Y-intercept is 0, -7. If you're getting stuck on those, that would be where you would want to ask a question in class so we can go over how I did that. What is the graph of this? So how to graph a linear equation? If you know 2 points, that's all you really need, okay? You can graph equations a lot of different ways. You can just give yourself an XY table and just put in numbers and get out numbers. Like, that's one way. But a lot of times it's way easier than that. If I know what the slope is and I know what the starting point is, then I'm good to go. Step 1, plot the y-intercept. Step 2, use the slope to find another point. Step 3, draw the line. Now, I always go one more so that I have 3 so I can make sure I didn't make an error. But that's really it. So if we have 4x minus 7y equals 14, I'm going to get the y by itself, okay? So I'm going to subtract 4x from both sides. So I have -7y equals -4x plus 14. Divide both sides by -7. I have y equals 4/7 x minus 2. Now, guys, you don't have to have graph paper. You can sketch these, and that's fine with me. If you are a graph paper kind of person, that's fine too. Go ahead and get yourself some. some of you are going to want it, some of you need it. I understand the feeling of needing it. So I throw a quick graph on here for myself. If you go to the class webpage, you can print off some graph paper. I have it there in the files section. But so the y-intercept is -2, and 4/7 up 4. Let's see, over 1, 2, 3, 4, 5, 6, 7. So there's 1 point. And then I'm going to go down 4, which I can do as long as I go left 7. All right, and I'm even going to get out my ruler here. Use my ruler. This is fancy. Let's see, line my ruler up. I got rulers in class if you guys need them so that your lines don't look like a hot mess. All right. So here's mine. There's my line. I make sure that when I draw my line, it goes the length of the graph. I also make sure I put arrows on the end of it because it's a line, and you learn in geometry lines go forever. That's it for the notes, guys. Hope you had fun. I will see you next time. Remember to ask me questions in class, and remember that when you get the coffee, when it says extreme caution, coffee hot, it's true. Unless it's iced coffee, and then if that's hot, somebody messed up your order. See you next time. Bye.